few years ago, if one had to navigate one's way to any location, the entire process consisted of a heavy number of phone calls to friends and family members who might know the exact address, or a few stops along the way to ask the strangers and a police officer for directions. Today, we can do it by logging in the necessary data into the GPS of our car. GPS navigation is one of those small revolutions that has slowly, but surely in a discreet manner, changed the style of our lives. A few years ago it would have been nothing short of a small miracle if there were a small box in our cars telling us where to go and how to get there. Origins. Like many of modern-day innovations, GPS navigation started off as a military development, starting in 1978 with the launch of the first GPS satellite. It was originally intended for use in deploying weapons along unknown terrains, without the risk of using scouts or infantry to actually map out the terrain. The full deployment of the GPS satellites was completed in 1993 with the launch of the 24th satellite, and it became fully functional in 1995. Originally known as Navstar, it was off limits to the general public until 2000. How it works. GPS navigation works through a process known as trilateration. At any given time, there are a minimum of 4 maximum of 12 satellites visible to any GPS-enabled device anywhere. The GPS satellites are in a fixed orbital pattern and circle the Earth twice every 24 hours. The device communicates with the overhead satellites using high-frequency, light-speed radio signals, calculating the distance between the satellites and the GPS device. Technically, only 3 satellites are needed for this kind of communication to take place. However, for the sake of accuracy, most GPS devices communicate with a minimum of 4 satellites. Functions. A GPS-enabled device is a handy addition to any outdoor man's kit. It is not only used for hiking, trekking and mapping of the routes, instead it has helped save countless hours of the commuters on the highway by providing them valuable information regarding weather conditions, speed and driving conditions. However, there are various factors that may or may not hamper the efficient functioning of your GPS device, and weather is one of the most important factors. A cloudy sky may hamper the signals to and from your GPS device, drastically reducing the efficiency of navigation. Another important factor is the map database provider, which your specific GPS device uses. Apart from the weather and database providers, terrain also proves a crucial factor in determining how and when your GPS device functions.